Hello, grade 10 students. Welcome to the Mortiz National High School Mathematics 10, Quarter 1 on Sequences and Arithmetic Sequence. And I am Ma'am Jeanette Hoves Ortega, your teacher. And here are the following to be observed using the module. Follow carefully all the contents and instructions indicated in every page of this module. Write on your notebook or any writing pad the concepts about the lessons. Writing enhances learning, which is important to develop and kept in mind. Listen attentively and focus on solutions shown. Apply what you have learned by solving on your own. Enjoy learning! Before we proceed with our discussion, here are our learning objectives. So at the end of this module, it is expected that you should be able to generate patterns, illustrate an arithmetic sequence, and determine arithmetic means and the nth term of an arithmetic sequence. Let's start our lesson with this preliminary activity. What's next? Each item below shows the pattern. Answer the given questions. The first one, what is the next shape? Correct. The answer is a square. What is the next number for number 2? Definitely yes. The answer is 20. What about the next number in number 3? Absolutely correct. The answer is 2. And last, what is the next number in number 4? Very good. The answer is 16. The set of shapes and the sets of numbers in the above activity are called sequence. And what is a sequence? A sequence is a string of objects that follows a particular pattern. For example, we have 3, 6, 9, and 12. The terms in the sequence are denoted by a sub n, where n is the term number. Thus, a sub 1 is equal to 3, a sub 2 is equal to 6, a sub 3 is equal to 9, and a sub 4 is equal to 12. There are two kinds of sequence. We have the finite and the infinite sequence. For the finite sequence, we have examples as 3, 6, 9, and 12, while for the infinite sequence, we have 10, 12, 14, 16, and so on. So what's the difference between the finite and infinite sequence? Your observations are correct. So for the finite sequence from the given examples, it has exactly 4 terms, and the sequence stops at 12. While for the infinite sequence, as you can see, after the number 16, there are 3 dots, which means to say that the sequence is to be continued. So, a sequence is said to be finite if it has a last term, while it is infinite if it has no last term, denoted by 3 dots, which we call ellipses. That signifies it will just continue. Let's now have an example. Find the next 3 terms of each sequence. For letter A, 25, 17, 9. Letter B, 0.5, 1.5, and 4.5. And for letter C, we have 1, -4, 9, and -16. So what do you think are the next 3 terms for letter A? Very good. The answers are 1, -7, and -15. What about letter B? Correct! The answer is 13.5, 40.5, and 121.5. What about letter C? Very good. The answer is 25, -36, and 49. Example number 2. Analyze if the given sequence is finite or infinite sequence. Let's have letter A. What do you think is the answer? Is it finite or infinite sequence? Correct. It is a finite sequence since it has exactly 5 terms. How about letter B? Very good. The answer is infinite sequence since there is ellipsis at the end that signifies it continues infinitely. And for letter C, is it a finite or infinite sequence? Yes, definitely. The answer is finite sequence. Yes, in the example, it has ellipsis, but the ellipsis was used between 20 and 100 to indicate that it will continue the pattern up to 100 only, which is the last term of the sequence. Did you get it, class? Let us now proceed to the first type of sequences, the arithmetic sequence. Let us study each set of numbers and find for the last term. For number 1, what will be the answer? Very good. The answer is 13. What about number 2? What will be the next number after 35? Correct. The answer is 45. What about number 3? What will be the answer after number 6? Definitely correct. The answer is 3. So let's try to observe the sequences. Let us try to explore arithmetic sequence by getting the difference of two consecutive numbers from right to left. So we start with number 1. So 13 minus 10, the answer will be positive 3. And 10 minus 7, what will be the answer? Still 3. Then 7 minus 4, what is the answer? Yes, it's still 3. And 4 minus 1 will give us 3. So, the difference between two consecutive numbers for number 1 is positive 3. We have the same differences. What about number 2? So we start with 45 minus 35. What will be the answer? Yes, it's 10. And 35 minus 25? Correct. It's still 10. And 25 minus 15 will give us 10. And 15 minus 5 will give you 10. So what's the common difference? It's still 10. And for number 3, we try to subtract. We start with 3 minus 6. The answer is negative 3. And 6 minus 9 will give you negative 3. And 9 minus 12 will give you negative 3. And 12 minus 15, the answer is negative 3. Do we have the same differences for the consecutive terms in number 3? Yes. And the answer is negative 3. And that makes the sequences to be arithmetic. So what is an arithmetic sequence? So an arithmetic sequence is a sequence where every term after the first is obtained by adding a constant called the common difference. And the common difference is denoted by small letter d. So, as we can see to the example, in number 1, there is a common difference of the consecutive terms, and that is positive 3. And for number 2, there is a common difference which is positive 10. And for number 3, there is a common difference which is negative 3. So, each sequences in these three numbers are called arithmetic sequence. Did you get it? Very good. Let us check your understanding on arithmetic sequence by this activity. So identify the following sequences if it is arithmetic or not. For number 1, we have 2, 4, 16, 32, and 64. And for number 2, 5, 7, 9, 11, and 13. And for number 3, we have negative 10, negative 4, 2, 8, and 14. So let's start. For number 1, is the given sequence in number 1 arithmetic or not? What do you think? Correct. The answer is not arithmetic. Why? Let's try to explore the differences of the consecutive terms. We can start also from 4 and 2 because 4 comes right before 2. So 4 minus 2, the answer is 2. The next, 16 minus 4, you will have 12. And 32 minus 16, you will have 16. And finally, 64 minus 32, what do we get? The answer is 32. What do you notice on the differences of the consecutive terms? Okay, correct. There is no common difference that makes the sequence in number 1 not arithmetic. Did you get it? Well done. Let's have number 2. 5, 7, 9, 11, and 13. What do you think? Is it arithmetic or not? Correct. The answer is arithmetic, and the common difference is 2. Let's try to check. Getting the common difference? Between 7 and 5, we have 2. And 9 and 7, the answer is 2. And 11 minus 9, the answer is 2. And 13 minus 11 will give you 2. Therefore, we have a common difference which is 2 that makes the sequence in number 2 arithmetic. Number 3, we have negative 10, negative 4, 2, 8, and 14. What do you think? Is the answer arithmetic or not? Okay, very good. The answer is arithmetic and the difference is 6. So let's try to explore it. So we start from, yes, negative 4 minus negative 10. What happens to negative 10? It becomes positive 10, definitely. So negative 4 plus 10, what will be the answer? Yes, it's positive 6. The next, 2 minus negative 4 will give us 2 plus 4. So the answer is positive 6. The next, 8 minus 2, what's the answer? Yes, it is still 6. And 14 minus 8, the answer is 6. So, is our answer correct? Yes, the answer is arithmetic because we have a common difference which is 6. Did you get it, class? Well done. What if you're given a task to find the last term of a sequence with 500 terms? What are you going to do? So, you're going to have listing, right? Correct. But there is an easier way to find for the last term of an arithmetic sequence. That is using this formula. A sub n is equal to a sub 1 plus the quantity n minus 1 times d, wherein a sub n is the nth term, or what we call the last term. While a sub 1, of course, by the subscript 1, it means it is the first term. And for n, this is the term number or the number of terms. And for d, as what we have discussed a while ago, that is the common difference. So let's try to explore this formula by an example. So what is the 8th term of the sequence below? 3, 5, 7, 9, and 11. So by listing, of course, what comes next after 11 will give you 13. Then, correct, 15. And then the 8th term will be 17. So let's try to use the formula if we're going to get the same answer, which is 17, by not listing, but by using the formula. So we have the steps. Step 1, identify the given. So from the formula we have, so a sub 1 is 3. The n is 8, and the common difference is 2. Then identify what is required. So we're looking for a sub 8. Then we're going to use the formula. So a sub n is equal to a sub 1 plus the quantity n minus 1 times d. We substitute the values, correct? And so we have there a sub 1 is equal to 3 plus your n is equal to 8 minus 1, and then the d becomes 2. Then what are we going to do first in our example? Correct. We're going to subtract first 8 minus 1. And what's the answer? Okay, the answer is 7. Then what comes next? Very good. We're going to multiply 7 and 2. So what will be our answer? So the answer becomes 14. Then finally, 3 plus 14 will give you 17. Did we get the same answer? Okay, correct. So which is easier to do? Are we going to list down or we're going to use the formula? Okay, so it's up to you guys, but if we have a bigger number of terms, then we need to use the formula. Okay, so the 8th term of the arithmetic sequence is 17. Okay, let's have example number 2. What is the 20th term of the given sequence? 22, 18, 14, 12, and 10. Okay, so using the formula, what will be the first step again? Correct. We identify the given. So what is a sub 1? Okay, the answer is 22. Then, what's next? The n. The n is 20 by the word 20th term. So we are looking for the 20th term. It means to say there are 20 terms given. And for the common difference, what's the common difference? Okay, the answer is negative 4. Then after identifying the given, what comes next? Okay, step 2, identify what is required. And we are looking for what? Okay, correct. The ace of 20 is unknown. Then after that, what comes next? Okay, we write the formula. And what's the formula again? Yes, a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Then, definitely the next step, we substitute the values. So, writing the formula, what will be a sub 1 again? That is 22. Then n, 20 minus 1 times the common difference, which is negative 4. Correct. Then what are we going to do first? Yes, we are going to subtract 20 and 1. So 20 minus 1 will give us positive 19. Then what comes next? Yes, we're going to multiply 19 and negative 4. The answer is negative 76. Then finally, We're going to subtract 22 minus 76. What is the answer? Okay, your computation is correct. The answer is negative 54. So, what will be our statement? The 20th term of the arithmetic sequence is negative 54. Did you get it, class? Well done. Let's have example number 3. What is the first term of an arithmetic sequence given that the 9th term is 24 and the common difference is 2? So in our example number 3, so we're looking for the first term already. So identify the given. Anyone? Okay. So ace of 9 is 24 from the word 9th term. What's next? Yes, the common difference is 2, so it's denoted by letter T. Correct. Then what is n? Okay, why 9? Because of the word 9th term in the given statement. Then identify what is required. We are looking for what? Yes, we're looking for a sub 1 because of the word first term. Correct. Okay, so next we write the formula again, and the formula is a sub n is equal to a sub 1 plus n minus 1 times d. Then our step 4, we substitute the values. So writing the formula, so what is a sub n plus? Okay, correct. The answer is 24, and a sub 1 still unknown, so we're going to place a sub 1 still. Then our n is 9 minus 1 times d is 2. Let's check. Okay, so we're going to substitute a sub 9, and the answer is 24. Then what are we going to do with 9 minus 1? Of course, we're going to subtract, and the answer is 8. Okay, then after that, what's next is we multiply 8 and 2, and it will give us 16. Then, what are we going to do with 16 to find for a sub 1? Correct. We're going to transfer 16 to the other side of the equation. So, what happens to 16? Okay, very good. The sign of 16 becomes negative. So, we have now 24 minus 16 is equal to a sub 1. And what will be the first term now? So a sub 1 is equal to 8. Did you get it? Okay, so the first term of the sequence is 8. Okay, let's have example number 4. Insert 4 arithmetic means between 5 and 25. So anybody from the class, what are we going to do first? Okay, so we're going to list it. We will have the sequence 5, then we're going to insert the word 4. So 5, then 1, 2, 3, 4. Then the last term is 25. The next, a sub 1 is 5. Then a sub 2 is the first blank, followed by a sub 3, a sub 4, a sub 5, and a sub 6. Then after that, we identify now the given. So what is a sub 1? The answer is 5. Then a sub 6 is 25. And what do we need to find again? We're going to have the number of terms, which is 6. And what do you think will be the first one to be found? Are we going to get the arithmetic means already? Okay, so we need to get what? The common difference, correct. So after getting the common difference, we can now find for a sub 2, a sub 3, a sub 4, and a sub 5. Okay, so we write the formula again, and that is a sub n is equal to a sub 1 plus n minus 1 times d. And we substitute the values just the same. So a sub 6 is equal to 5 plus 6 minus 1 times d. Then, we're going to simplify first what is being grouped. And that is 6 minus 1 will give you, okay, 5. Then, what are we going to do with 5 and d? So we multiply, the answer becomes 5d. What about 5? Okay, so 5 will be transposed to the other side of the equation. It becomes negative 5 is equal to 5d. And we subtract 25 minus 5. There. The answer is 20 is equal to 5d. Then to find for the value of d, we're going to divide both sides by 5 to cancel the coefficient of d here, which is 5. Okay, so 20 divided by 5, the answer is 4. So the common difference is 4. Then what are we going to do with that common difference? Anyone? So yes, we're going to use this common difference to find 4, a sub 2, a sub 3, a sub 4, and a sub 5. So from the given sequence we have a while ago, we're going to insert 4 arithmetic means between 5 and 25. And using the common difference 4, we're going to add it from 5. So 5 plus 4 will give you 9. Then 9 plus 4, 13. And 13 plus 4, 17. And 17 plus 4 will give you 21. And to check where there is still a common difference between 25 and 21, the answer is still 4. Therefore, what are the 4 arithmetic means to be inserted between 5 and 25? We have 9, 13, 17, and 21. Did you get it? Well done. Thanks for listening. So I'll be leaving you a quote to ponder on. The only way to learn mathematics is to do mathematics. So for you to be able to learn, you have to explore and solve. Good luck!